Chapter 3, Section 7, Perpendicular Lines in the Coordinate Plane. The slopes of perpendicular lines postulate says that in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical and horizontal lines are perpendicular. If we go back up and look at the fact that to be perpendicular, lines have to have a product of their slopes equal -1, there's another way to say this, which will still get you a product of the slopes to be -1, but you could say that the slopes have to be the negative reciprocals of each other. When I say negative, I mean it's going to be the opposite sign. So if you have a positive slope, it would have to turn into a negative slope, and a negative slope would turn into a positive slope. And then the reciprocal, if you remember, is when you flip the numerator and denominator of a ratio. So if you had a negative reciprocal of the slopes, then the two lines would be perpendicular. They would also multiply together to equal -1. So it still makes the slopes of perpendicular lines postulate true. The first example says find each slope, then find the product of the slopes. If you look at line P and line Q, notice they're both sharing the point -1.8 and -0.6. This looks like it might be nice to count rise over run to find the slope, but because we do have that point with decimals in the ordered pair, we do need to go ahead and use the slope formula. So for line P, I'm going to have 3 minus -0.6 over 0 minus -1.8. When you are subtracting a negative, remember that's the same as adding a positive, so 3 plus 0.6 is 3.6, and then we have a positive 1.8. This can be simplified. 1.8 does go into 3.6 two times, so the slope simplified is just a whole number 2. Remember, we can write any whole number over 1, so the slope of line P is 2. You could also think of 2 as 2 over 1. For line Q, I'm using the point -3, 0, and the -1.8, -0.6. The slope formula, we have 0 minus -0.6 over -3 minus -1.8. Again, subtracting a negative is the same thing as adding a positive, so we have 0.6 over -1.2. 0.6 does go into -1.2 two times, so the slope for line Q is -1/2, or 1 over 2. If you look at the slopes for line P and line Q, we have 2 over 1, and then we have -1 over 2. That is the negative reciprocal of each other. To be sure though, so I'm already thinking possibly I have perpendicular lines. To be sure, I can multiply the two numbers together. 2 times -1 over 2. Remember, we can write 2 over 1. So we have 2 times 1 is 2, over 1 times 2 is 2, and a positive times a negative is a negative. So this does equal -1, which does go ahead and tell me that line P is perpendicular to line Q. The next example says to decide whether line PQ and line RS are perpendicular. If you notice, again, we have two lines that are graphed on a coordinate plane. In this case, we do have whole numbers for our ordered pairs, so it is going to be nice to count rise over run. Let's start with line PQ. To go from point P to point Q, I have to go down 1, so my rise would be a -1, and I go to the right 7. So the slope for line PQ, rise over run, is -1 over 7. And for line RS, to go from point R to point S, I have to go up 5 and over to the right 1 unit, which gives me a slope of 5 over 1, or just 5. Now, if you notice, -1 over 7 and 5 are not negative reciprocals of each other. Again, I'm going to go ahead and use the postulate, so I'm going to show that when I multiply -1 over 7 times a positive 5, it does not equal -1. So lines PQ and line RS are not perpendicular. The next example says to decide whether lines are perpendicular, we have line A with an equation of y equals -2/3x minus 1, and line B which has an equation of y equals -3/2x plus 1. Both of these lines we are given an equation in slope-intercept form, y equals mx plus b, where m is the slope. So for line A, the slope is -2/3, and for line B, the slope is -3/2. Notice that both of these slopes are negative. They have been flipped. We have found the reciprocal of each slope. However, since they are both negative, they cannot be perpendicular because a negative times a negative is a positive. When you multiply -2/3 times -3/2, you will never get -1 because a negative times a negative is always a positive. The next example says to decide whether the lines are perpendicular. We're given line E, which is -2x plus 7y equals -4, and line F, which we have 7x plus 2y equals 10. Notice that we are given the equation of two lines, however, they are not in slope-intercept form. To be in slope-intercept form, I need y by itself. So we need the equations of the lines to be in slope-intercept form. To do that, we're going to solve for y. Let's start with line E. To get y by itself, my first step, I'm going to add 2x to both sides to give me 7y equals 2x minus 4. To solve for y and get y by itself, I need to divide by 7 on both sides. When I divide by 7, I get y equals 2/7x minus 4/7. I'm going to do the same thing for line F. For line F, I'm starting with 7x plus 2y equals 10. The first thing I need to do is subtract 7y from both sides. I have 2y equals -7x plus 10. Notice I'm putting my x first because to be in y equals mx plus b form. Now I need to divide by 2, which gives me y equals -7/2x plus 5. When you look at the two slopes, 2/7 and -7/2, we do notice that they are the negative reciprocal of each other, and they will multiply together to equal -1, which tells us that these two lines are perpendicular. The next example says line G has an equation of y equals 3x minus 2. Find the equation of a line H that passes through point 3,4 and is perpendicular to G. The slope of a line perpendicular to G, which has a slope of 3, has to be the negative reciprocal of a positive 3. So we know it's going to be a negative. Remember, 3 can be written as 3/1. So it has to have a slope of -1/3. Now, we're given a point that this line passes through. We can use this point to find our y-intercept, or b, by plugging it in for y and x. We know that the slope has to be -1/3, so we can say that y equals -1/3 x plus b. I need to find b though, so I'm going to plug in 3 for x and 4 for y, which is from my point that they give me, that the line passes through. -1/3 times a positive 3 is a -1. So I need to add 1 to both sides, which gives me 5 equals b. I know the slope and I know the y-intercept, so I can write the equation y equals -1/3 x plus 5. Today's assignment is on page 175, numbers 8 through 44 even, 51, 56 through 62 even.